lecture. Okay, any question from last lecture? Okay, so about sharing the slides, like I have said already to Varanasi Sai, I'll be sharing the slides once I finish this chapter. Otherwise, what I need to do is I need to share the slide partially. Okay, and then at a time I need to stitch it again and send you the like the whole chapter slide. So I prefer to share it at once, maybe when it is completed, sometimes in the next week. Then you can go through and we can have a doubt clearing session afterwards. Okay, if you have any doubt on this particular chapter.
Sir, about evaluation, how many tests are you planning?
About the evaluation tests, you can expect around 6-7 tests. More than that I cannot take, and less than that will not be good to evaluate. Like there are supposed to be like mid-sem and end-sem, right, which contains let's say 70%. So each test you can think about 10% weightage in that way. So 6 to 7 tests I will take. Any other question?
Sir, can we like a group of 6 members is okay, or only 5 members?
I see around 41 students, right? So one group will have 6 students, other group will have 5 students. So only one group will be having 6 students, other groups will have 5 students.
Okay, sir.
Okay. Okay. So today what I'm going to do is I'm going to give you a quick recap what we discussed yesterday. We talked about atmospheric circulation and we ended the class with tricellular model of the atmospheric circulation. Okay, so basically if you consider the Earth as a whole, so there are 3 cells which can represent the atmospheric circulation happening around starting from the equator to the pole. When you move from equator to the pole, these 3 type of atmospheric circulations you can expect. Okay, so today what we are going to do is we are going to yes
sir.
Yes.
Sir, why the
Yes,
wind
Akash.
doesn't flow from why wind doesn't flow from one cell to the another? Because you see there is only circulation in a particular cell, so it is confined to that cell only. So why there is no intercell circulation?
This is a very ideal scenario, but what actually happens, or in real life situation, there are transfer of the mass or air mass from one cell to the other. Okay, it happens during if you have storm or cyclone, or in that type of situation. When I talk about why there are certain type of, or the cells are formed, you can see that when air gets heated up, it goes up, right, from the equator, and it has a tendency to move further also. But what it experiences by this horse latitude, it is so heavy. Okay, it cannot carry that much amount of water vapor or moisture content. So some of the air falls down. Okay, so that's why it completes a cycle here. You can, practically what happens, there is still some dissipation of the air which can move to the other cell. Okay, but most of the air which are confined to this particular cell, in the equator side, there will be one particular defined cell. A few will be or few air mass will be migrating to the other cell. Okay, it is not that they will not migrate, but yes, they will migrate also. There is no device or mechanism which is stopping them to migrate. Okay, but this is the ideal scenario or the ideal representation. All right.
Okay, sir. Okay.
So coming to the atmospheric, like we saw that there are a lot of circulations. So now how do we define the atmospheric condition? In general, you know that the atmospheric condition is termed as weather of the a particular place or weather in a particular time. Okay, so what is weather? Weather is the state of the atmosphere at a given time and space, and what you are going to observe in that when we say about weather of the atmosphere. So basically you try to investigate temperature, moisture condition, wind velocity, and its pressure. Okay, so these are few of the parameters that you look for when you define a weather of the atmosphere. Okay, then there are few weather stations which are defined at certain locations. We will come to what are the ideal location of the weather station. Generally, those are defined very far away from the urban areas. Okay, wherever you have flat land or there is no human activities, so very far away from the urban land. Generally, the weather stations are defined so that you don't get disturbance or the turbulence in the atmosphere, and you can actually monitor what is the natural weather condition. Okay, because in the urban or city areas, the weather can be influenced by different industrial activities. Okay, so that's why many a case the weather stations are defined or located very far away from the urban areas. Okay, so what are these weather stations do? They are equipped or they have facilities to monitor this atmospheric condition, and they have several instruments. Basically, you can see that to define a weather, we need information for the temperature, moisture, wind velocity, barometric pressure. Then there are other things like humidity also, amount of rain. There are many other factors. So these weather stations are equipped with so many instruments that will define or measure these parameters. Okay, so that is basically the definition of weather. And okay, so this is we discussed about weather, but sometimes we also say climate. Can some of you tell what is climate? What is the difference between weather and climate?
Weather is a climate is defined over a larger period of time.
Yes, sir. Climate is defined over a longer period of time. We can say weather of a particular place for a longer period of time. Moisture,
Okay.
velocity, and temperature.
Yes, so in general, you can say that, okay, we measure the weather information in a shorter period of time, but those are also average quantities. Those are not instantaneous quantities. Like when you define a weather of a place, so you measure for 1 day or 2 days. Okay, so like 24 hours, 48 hours, you define weather. But when you talk about the climate, again, you do the average measurement, but this average measurements are spread over longer duration. Like you have said, it can be like for 15 days, for a month, something like that. Okay, so if it is the duration is large, so all these measurements will be there, and but the duration of measurement will be larger. Okay, so that is what the climate or climatic situation is defined. Again, these weather stations are also used to monitor the climate of a particular place. Okay, now, so today we are going to discuss various instruments. Those are used in the weather stations. I will be discussing about some of the instruments. There are many others, and we will not be able to cover it in this particular course, and that is also not the main theme of the course. Okay, so the important ones I am going to discuss. So first one is to measure the pressure. So there are various pressure measurement instruments already, you know. So the first one which is used for the atmospheric pressure measurement is barometer, and this is a vertical tube barometer schematic I have shown here. The working principle, already you are aware of it. Just to recap, what you do is you take a reservoir and some barometric fluid. In general, we take mercury, and on that reservoir we dip a vertical tube. Okay, a vertical tube is dipped into it, and at the beginning you can think that the top lid of the tube is open. So by that, everywhere there will be atmospheric pressure. Now what do? You try to close the top lid and create a vacuum in that. Okay, and what is going to happen? Since the pressure on the top lid is different than the atmospheric pressure, basically the vacuum pressure and the atmospheric pressure, there will be a rise of the barometric fluid, and this rise will be decided based on what kind of fluid you are using, whether you are using mercury, whether you are using any other type like water or alcohol. So based on that, this height will be decided. Okay, and from the balance of the weight of this liquid column with the pressure difference, you can basically find out what will be the atmospheric pressure at that location. Okay, so this is quite simple and straightforward. Already some of you, I mean most of you have studied about it. So the equation that is generally used here you can see is PA will be equals to rho GH. Okay, PA is your atmospheric pressure and the vacuum pressure is 0, right? So PA will be equals to this is rho GH, and this equation is defined based on the Torricelli pressure head. Okay, so this we have studied. You might have studied in the introduction to aerodynamics or some fundamental fluid mechanics course. Okay, so here rho is your density of the barometric fluid, G is your acceleration due to gravity, and H is the height. Okay, so with this principle, can you tell me what is the water head required if you want to measure the atmospheric pressure at the sea level, standard atmospheric pressure? If the liquid is water, okay.
10 point something, sir. 10.1 meter column of water.
You can calculate and tell me to be more accurate. It is 10 point something. Yes.
Sir, it's 10.4 meters of water.
Okay, so it is nearby. You are telling a little bit higher number. So it is 10.3334, something like that. Okay, so 10.3 is, I mean, the suitable value you can take. Okay, so there are different types of barometer. To give you just a quick overview of the types of barometer. The first type is siphon barometer. So in this, instead of having a reservoir of what do you call barometric fluid, what you do is you just take a U-tube. Okay, so in this U-tube, you fill, like the same arrangement is done generally. There are two leads. One is the longer one, the other one is shorter one. On the longer one, you create a vacuum on the top side, and the other side is open to atmosphere. Okay, and due to the pressure difference, there will be rise in the liquid column, and the rise from this difference in the height. Okay, the height of the liquid in the short limb and the long limb, the difference in the height, using that you can find out what will be the barometric pressure or the atmospheric pressure at that particular location. Okay, so it is again very straightforward. It is not that difficult. Okay, then the third one is 14 barometer. 14 barometer is a more exact and accurate type vertical tube barometer. Why it is so? So because here you have vernier scales attached to the measurement, so you can get a better reading of the barometric height. So that's why since you have better scale arrangement here, so you get a better resolution of your data. So what is the difference between this 14 barometer and vertical tube barometer? So here in this case, the reservoir, at the bottom of the reservoir, you have a leather bag. Okay, so what you do when there is a change in the barometric head, like when you move from one location to other location, let's say from the sea surface to you're going to a hilly area, so barometric pressure drops or atmospheric pressure drops. So here you can actually change the height of the liquid in the reservoir. Okay, so you can see that there is a pointer here, ivory pointer. So if there is a change in the atmospheric pressure, this zero position of the free surface of the liquid will be changed. Okay, so some cases it will be larger, some cases it will be smaller than this this pointer location. Okay, so that thing you can adjust by this screw arrangement. Okay, to make it zero. once you fix the 0 position, then on the top side you have basically using this vernier scale, you can measure what is the height of the liquid column. Okay, so using that, you can again do that. You can use the equation what we have seen, PA equals to rho GH. And you can find out what is the atmospheric pressure. So here it is more precise and accurate because you are basically doing it in a precise manner. Like you have a pointer which is showing you a 0 position, then you have vernier scales which is also showing you the exact head of the liquid column. So that's why it is more precise. Okay, but the overall working principle is same as your previous vertical tube barometer. Okay, then the third one is aneroid barometer, which is different than the previous ones. Here you don't use any barometric fluid. Okay, so in the previous ones we need to use some type of barometric fluid, like mercury is the most preferred one. But the problem with that is carrying the mercury to different locations will be difficult, and sometimes it is also toxic if you encounter some accident or so. So alternatively, you can use this aneroid barometer. Basically, what is done in this case, you take a circular type of box, okay, which has corrugations. Okay, so this is a circular type of box, and if I take a cross section, it will look like this, and there are different corrugations. Okay, and at the beginning you create a vacuum in it. Okay, and or partially vacuumed. Now what you do is you calibrate this particular arrangement of the tube, which is, or cell, which is generally called Sylphon cell, and calibrate with the standard atmospheric condition. Let's say you calibrate at the sea level and make it 0 first, then you take it to somewhere else. And you can see that due to the change in the pressure condition or atmospheric pressure condition, this particular cell or the box will be either compressed or expanded. So based on that, the gauge reading will be also different. Okay, so that is what basically this aneroid barometer, that is how it works. Okay, and this is the resolution of this particular device can be further enhanced. How you can do that? You can increase the number of this corrugation or generally we don't change the material, so German silver is preferred. If there is more flexible material like spring steel also you can use, which can give you a better resolution, or by that what I mean is better deflection with the small change in the pressure. Okay, so that is possible to improve. I mean, that is how you can improve the resolution of the aneroid barometer. Okay, so this is about the barometer. Okay, any question? Okay, so next we move on to the another device that is commonly used in the weather station, as well as you might have seen in some of the industrial areas like chemical factories or in airport also. So what is it? This is generally called windsock. Okay, so it is a windsock. You might have seen this, right? So it comes in this particular color arrangement. Orange and green stripes are there, and this is made up of some fabric. Okay, and it's a conical fabric bag, you can say. So these colors are not done just for the visual purpose, but it is also done in such a way that, or the distance between the two stripes are done in such a way that it gives you some form of measurement. Okay, may not be directly highly precise measurement, but qualitatively you can say about this is the wind speed and the wind direction. Okay, so this device is particularly used to determine the wind direction as well as the wind speed. So here I have shown these color codes. What does it mean? So if when there is a strong wind, generally what happens when there is a strong wind, this whole thing will be stretched. If there is not so strong wind, it will be limped. Like you can see that if there is no strong wind, so it will be limped by deflecting few of the a pure part of this particular bag, and the other part will be just limped. So generally each stripes indicates 3 knots. Okay, so 1 knot is equivalent to 1.85 kilometer per hour, something like that. Okay, so to be this approximate value, so 3 knots is one particular stripe indicates. So this is, since you see that on this particular figure, one stripe is fully stretched, the others are limped. So it is approximately, you can say that the wind velocity is 3 knots. In the similar way, you can also calculate for the other ones. Okay. Now, one thing is the wind direction is opposite to the direction where the windsock is deflected, right? That you can see, right? Now you can see that see, if the wind is blowing from west to east, the windsock is deflected towards east. Okay, because it is blown by the wind. So the wind direction is not from the east to west. Okay, when you see this thing, which is quite obvious, but for those who are not able to understand, the wind direction will be always from the opposite side. So west to east, if it is deflected towards the east. Okay, and if the wind is steady, then there won't be any oscillation or gustiness in this particular windsock. But if the wind is fluctuating, if there is some gustiness is there, so it may starts to flap. Okay, if the wind is steady, it is not going to oscillate. So with this device, actually, mostly the pilots, it is very helpful for them. They can simply gauge what is the current wind velocity and the direction, and they accordingly set the parameters when they do the flight. Okay, so that is quite useful. Then the third device is ceiling balloon, or it is also called weather balloon. In this case, there are various measurements are taken. Generally, what you do, you take a balloon and fill it with either helium or hydrogen, and when it is filled properly, generally the ideal rise rate, like you can see that the helium and hydrogen, they are I mean, when you fill it with a proper amount, it can float at a certain velocity. Okay, depending on how much amount of mass of this helium and or hydrogen is there, the exact or the better rate of rise is 140 meter per minute. Okay, if it is properly filled and with it is steady atmospheric condition. So you try to look for this particular number. If it is not filled properly, in any ways you can calibrate it. Anyways, like if it is not filled to that extent, so what do? You fill the balloon and allow it to float. And there are many other devices you can attach to it. Like you can see that there is this particular box which might be carrying thermometer or pressure measuring devices also. So, or even humidity sensors are also can be installed in this particular box. So when you float this balloon, this information can be obtained, okay, at various heights of the atmosphere. Generally, it is used to find out what is the height of the cloud from the ground level. Okay, so the balloon will rise to certain extent, and after that its rise will be reduced, or it may be just stagnant if it encounters the cloud there for certain time. So you can measure the height of the cloud from the ground level. So that is all. That is what it is mostly used. And what happens, like, are you going to just scrap this device? Like once the balloon is floating up, it can go to the certain height. Okay, will it go to the space, or what is going to happen? What is the future of this balloon which is flowing up or floating up? Can someone tell me? Will it go to the space infinitely?
It will
No,
raise
sir.
a definite height and it will stay there.
It will stay there?
Yes, sir.
Why it will stay there?
Because the density of the helium means if as we go up, the density of the air is decreasing, and the density when the density of that part matches to the balloon density gas, then it will float there.
What about others?
So basically pressure will decrease.
So what is going to happen to the balloon?
Okay, it will expand, sir, and it will pop up.
It will pop up. Okay. So if the pressure is decreasing, if you go to the higher atmosphere, we discussed yesterday, the pressure will be reduced. So at certain time, the balloon will be bursted. Okay. Then those instruments what you have sent with the balloon, you are going to, basically those are very costly instruments. You are not going to just scrap them out, right? So there is this parachute, you can see that is generally attached to it, and once the balloon is destroyed or bursted, so that whole device will fall down at certain location. Okay, then you can recover that and use it again. So that is how this weather balloon or ceiling balloon generally works. Okay, so there is another device which is called ciliometer. So ciliometer is yes.
Like in case of any wind blowing, then will it not affect this ceiling balloon?
In what way wind blowing? Yes, it is definitely going to affect the ceiling balloon. That is what you can measure the wind velocity at that location. What is your concern? I don't get it.
Okay, are we trying to measure just the atmospheric pressure or what?
We generally measure the temperature, like I said at the beginning. What are the important parameters we are looking for when we define the weather of a particular place? So we either measure the temperature, pressure, wind velocity, the humidity at that location. So all those sensors can be fit in there. Okay, in that particular box, what you're seeing here. Okay, and you can see how it is varying with the vertical height. So that information is also quite important to predict the future, like how the weather is going to change or evolve with time. Okay, so that is why we investigate how the variation is happening with the vertical height.
Okay.
Okay. So we go to the next one. Next one is ciliometer. So this instrument is again used to measure the height of the cloud base. Sometimes if you have pollutant also, like highly polluted region, if there is a fire or smoke coming out from the chimney or highly polluted region, so you can use this laser ciliometer, so which can give you the height of the pollutant or the cloud base from the ground level. Okay, so how it is done? It is actually like the name itself. Here I did not mention laser ciliometer. There are coherent light source. Generally, laser source are used for this particular device. So you send a laser pulse which has a certain frequency and a wavelength. Okay, now when it goes and hit the cloud base, for example, as shown in this case, some of the light will be scattered back or reflected back. Okay, and using another receiver, you can actually find out what is the difference in the frequency of the light which is received back or the scattered back. Okay, using that difference in the frequency between the emitted light source and the received light source, you can actually find out what is the height. Okay, so using that calibration calculation, which we are not going to see it in detail. So basically, by seeing the frequency difference, you can measure what is the height of the for example, in this case, cloud base or your pollution from the pollutant from the ground level, that can be calculated. Okay, so something similar to laser Doppler velocimetry that we have seen in the, some of you might have studied in the previous course that I was teaching. So same principle, like during based on the frequency difference, you can find out what is the height of the cloud base, okay, or the pollution height of the pollutant. Then the next one is wind profiler. So wind profiler is used to find out the vertical distribution of the wind, basically the wind speed and wind directions that can be monitored. And how it is done, what you do is you have this particular space which has lot of radars or sodars. So radars and sodars, they use radio waves or the sound waves. Okay, so again, you send some of these radio waves or sound waves, and those waves will be, some of these waves will be reflected back or scattered back once they encounter the air particles. Okay, the tiny fraction of the emitted power will be scattered back, and from that you can do some calculation and find out how the wind profile look like in that particular region. Okay, so with this device you can actually see a large span of the wind velocity. You can see that it can be extended to quite a long distance. Sometimes it can be up to few kilometers even. Okay, then the other one is pan evaporation. So here we try to find out what is the effective evaporation rate, or by that you can also cross calculate what is the moisture content or humidity level in the atmosphere or in that particular region. Okay, so what you do here is you take a cylindrical vessel like this, and there are certain dimensions which are preferred, like I have mentioned here, and you place that on a wooden platform slightly above the ground level and monitor. So then you fill it with a certain amount of water. Okay, there should be graduation marks somewhere in this vessel. So you fill it up to certain level and monitor for, let's say, 6 hours or 12 hours or 24 hours interval. Okay, and try to see how much amount of water is actually evaporated or in a way consumed by the atmosphere or by evaporated to the atmosphere. From that you can find out what is the moisture content in that region. Okay, so it is quite straightforward. Then there is another, yes.
Sir, but evaporation is not purely dependent on the atmospheric moisture, right? Because the local wind
condition. Yes. So the thing is, when we are discussing about these devices in a separate way, but when they are used in a combined manner. Okay, so you monitor also the wind condition, you monitor the temperature, so everything will be monitored at the same time, and based on that you do the prediction. Normally whatever measurement we are doing, we are going to predict the future, how it is going to change in 2 days time or 3 days time. So that prediction can be done. Okay, so these devices are not separately used, they are combinedly used with all other things. Okay, does that make sense?
Yes, sir.
So if you know the wind velocity, wind temperature, then of course you can very well correlate that with the evaporation condition. Okay. So the next one is whole or all sky camera. So which is I think it's a very interesting thing to see, and you might have seen some videos in YouTube also. So this is a camera which is placed at a certain height where you can have a visuals for the horizon. Okay, so the camera is installed with certain type of lens which can give you 180-degree view of the horizon. Okay, and you can actually monitor how the cloud or in general the storms or sunset, sunrise, many things, many interesting things, the visuals can be obtained, and this is very beautiful to see. Okay, so you can see that this GIF file also shows, so there is formation of the movement of the cloud in certain region. Okay, so from this video also many a time you can cross correlate how actually the wind velocity is and the direction is based on the movement of the cloud, and you may be able to predict the storm condition. Okay. In general, it gives you quite interesting videos. Okay. Okay. So then there is another device which is called psychrometry or psychometer. So in this, what you do is you try to measure the humidity at a particular location, and how it is or how it is done. Basically, it contains two different thermometers, like you can see here. One is a dry bulb thermometer, the other one is called wet bulb thermometer. Why it is so? You can see that the pointer or the bulb of the thermometer, in one case it is open to the atmosphere, it is in the dry condition, whereas in the other one it is there is cotton soaked with the water. You just try to wrap on it. Okay. And you measure the difference in the temperature reading using these two thermometers at a particular place and a particular time. Okay, so that difference in the temperature will be actually governed by the atmospheric humidity condition. You can see that this dry bulb temperature will give you the temperature of that location. The wet bulb temperature, since if the atmosphere has lesser humidity or lesser moisture content, then there will be a lot of evaporation at that with that temperature condition. Okay, so that evaporation will try to reduce the wet bulb temperature or the wet bulb thermometer reading. Okay, so these two difference in the temperature reading, you can correlate what will be the humidity condition at that particular location. Generally, we use a psychometric chart also along with these two temperature data to find out the relative humidity condition in that particular location. Have any of you studied about this? Mostly the mechanical engineers, they have this thermodynamic course, and they do some examples, like they do some study on this. Any of you have studied psychometric chart and psychometric?
Yes, sir. We have.
Yes, sir. Yeah. In RAC.
Oh, that's good. That's good. So, so you guys are aware of how it works. Okay.
Yes, sir.
Okay. Then we come to the next device, which is called anemometer. So anemometer is basically used, as the name suggests, it is used for the wind speed measurement. Okay, and in some cases, it is used also for the wind direction. Okay. So anemometer, why I said the name suggests, anemo means wind, meter means you are measuring it. Okay, so it's a Greek word. So anemometer, it is used to measure the wind speed in general. Some cases like also the wind direction can be obtained with additional instrument attached to this particular device. So there are various anemometer. To give you a quick overview of that, the first one is cup anemometer, like you can see here in this particular figure. So what happens? So when there is certain wind, this cups will start to rotate. Okay, so the rotation happens because there is a pressure difference between this concave side and the convex side of the cup. Okay, due to that pressure difference, it starts to rotate, and that rotation will be again supported by the wind speed itself. Okay, so you can do the vector diagram and see that at one side of the cup it will be experiencing lesser speed, and the other side it will be experiencing higher speed. So due to that, it will continue its rotation. Okay, so the disadvantage of this device, like you can see that it is going to rotate irrespective of the wind direction. It doesn't care from which direction the wind is coming. So it is definitely going to rotate irrespective of the wind direction. So you can find out the wind speed, but you don't have the information about the wind direction with this device. Okay, so what we do is we generally use another vane or wind vane so that this whole device can be aligned along the wind direction with the help of this particular wind vane, and we can measure the wind direction as well as the wind speed. Okay, so that is how a modification is done normally. Yes.
Sir, like in this cup anemometer also, will not the speed of direction decide the direction of rotation of these cups?
You think? Is it symmetric to all direction or not?
Like if I have a wind coming from front side to then the direction of rotation will be like anti-clockwise, and if it's coming from the other side,
no, the direction of rotation is fixed. It will be always from convex side to concave side. It is just going to rotate. You can think that because it has a spherical symmetry. Okay, if you see in the 3 dimension, it has a spherical symmetry. So it doesn't care about wind is coming from which direction. It is just going to rotate. Okay, so you can further do the vector or force vector diagram and see. This is not
it rotates only in anti-clockwise directions.
Yes. Okay. So to know the wind direction, you need to attach a wind vane like the one shown here in the red color. There are many other wind vane designs. So I have taken something which is more general one. Okay. And then there is other type of anemometer which is also called propeller anemometer. So you can see here, instead of a cup anemometer, you basically use propeller blade. Okay, you can see here. And additionally, you attach a wind vane also. Okay, so here you have basically a tail fin. So based on the wind speed, this propeller will rotate. Okay, based on the velocity vector diagram. I think this is also well known to you. So due to the curvature of the propeller, if you have a incoming wind, it will start to rotate at certain speed. Okay, so you can have an additional sensor attached to it, and you can get the wind speed as well as, due to this wind vane or tail fin, you can get the direction also. Okay, so these winds measurement by this anemometer, cup anemometer or the propeller anemometer, basically they are average wind data. Okay, they don't give you instantaneous. Of course, you can get some instantaneous data from this propeller anemometer because they can, if you have a readout, sensor readout, digital sensor readout, then you can get instantaneous wind speed as well. Okay, but in general, to measure the instantaneous wind fluctuation, we use hot air anemometer or gusty anemometer. These propeller or cup anemometer are used for the average wind speed measurement. To get the instantaneous data or the gustiness in the wind, we use a hot wire anemometer. So in this case, what you do, you have a hot wire, like the name itself suggests. There is a electric conductive wire which you heated up to certain temperature, and if there is a wind blowing through that, so the temperature of the wire will be reduced, and by that temperature reduction, the resistivity of the wire will be also changed. Okay, so if the resistivity is changed, the amount of current passing through to maintain that particular temperature will be also changed. Okay, so using that relation between the change in the temperature and the change in the current requirement, you can find out what is the wind speed. Okay, so instantaneous wind speed can be obtained, and this frequency of this hot wire measurement can go up to megahertz. Okay, so very high frequency you can resolve with that. So these details we will not read here, so because there is separate course where I discuss about all these details of the hot wire anemometry. Generally, the hot wire size is in micrometers. Okay, and there are different principles like constant current anemometer, constant temperature anemometer. So those are not required here. So that is the working principle. Like, so the change in the temperature causes the change in the resistance of the wire. From that you can find out what is the change in the current requirement to maintain that same temperature again. Okay, so using this relation between temperature and the current requirement, the wind speed can be calculated. Okay. So this is about anemometer. Oh, okay. There is another device generally used for the pressure, velocity measurement. This is pitot static tube. Okay, so pitot static tube. This is also, most of you might have done experiments with that. So there are two tubes. One is used for the measurement of the stagnation point, and the other one is measured for the static pressure. Okay, so you get a stagnation pressure at the stagnation point and the static pressure at the static port. So what actually happens at this stagnation port, whatever wind is blowing, it comes to rest. Okay, and because of that, all its kinetic energy is converted to pressure energy. Okay, and when the wind starts to move on this along the side of the pitot tube at certain distance, it will and there are certain ports throughout the periphery of the tube which are used to measure the static pressure. Okay, so based on the difference between the two pressures, the stagnation point and the static pressure, you can actually use the Bernoulli's principle to find out what is the velocity of the wind speed. Okay, so I think this is also you have studied and might have done few calculations or examples. One thing you need to ensure, like there are various factors which affect the petrostatic measurements. One of the factor is misalignment. Okay, if the tube is not aligned along the wind direction, if the tube is not aligned along the wind direction, it might give you some reading or erroneous reading. So, but up to let's say 20-degree misalignment, still the acceptable results can be obtained. Okay, beyond that the errors will be quite large. Okay, so this also we're not going to discuss in detail, just let you know there are many factors that might affect the performance of the pitot-static tube. Okay. So generally they are used to calibrate other wind speed measuring devices like anemometer or hot air anemometer in the wind tunnel setting. Okay, so these pitot-static tube are also used to calibrate the other anemometers. Okay. Now there is another device which is called Neflo meter. So in this, what you do is you try to measure the amount of suspension or the concentration of the suspended particle in the atmosphere. Okay, so these suspended particles can be your pollutants, can be other suspended particle like cloud suspension is also possible to investigate here. So what you do is you take some amount of air and like you can see here, some amount of air is taken and you have a light source. There is a chamber where you have that particular amount of air passed through and the light is flashed on it, and you try to measure the scattered light along the perpendicular direction. Okay, so light is flashed here and you try to measure along this perpendicular direction through a photomultiplier tube. And based on the amount of intensity received, the change in the intensity received, you can actually calculate what is the suspension level or concentration of the particles, suspended particles present in the atmospheric condition in that particular location. Okay, so that is how it operates based on the reflectivity of the light, using the principles of reflectivity of the light. Okay. Then there are few more devices like rain gauge. So rain gauge is used to measure the amount of rain generally occurs in a particular region. So the device is shown here. It's just basically a cylindrical tube and you have a container there and you can measure the amount of rain in that region based on this graduating tube. Okay. So generally the unit of measurement is mm in this case. And similarly, you can use snow gauge. Snow gauge is used where you have snowfall and you try to measure how much amount of snow happened in particular duration. And the devices are more or less same. Okay. Then the measurement in the snow gauge can happen in two ways, like either in the snow form or in the melted form. Okay, so you can get a water equivalent if you are measuring the melted form of the snow, how much amount of the snowfall happened in terms of the water equivalent. You can also say that. There is another device which is called solarimeter. Solarimeter is used to measure the radiation during a particular day. how much amount of solar radiation received in a region, you can use solar emitter to find out that. So unit of measurement is watt per meter square in this case. So basically you have a black body or which can absorb all the radiation that is falling onto that, and using that you can find out how much amount of energy is actually received. Okay, and that's how it works. Okay, so solar emitter. Okay, so I think these are all devices which I feel important for discussion. There are many other devices which you can self-read. So in a weather station, these devices are not used separately, but to get a meaningful information, they are generally used in a synchronized manner or simultaneously. Okay, so any question? Okay, if no question, let me take the attendance.